Your actuator motor is sealed inside an enclosure, it's running hot, and you need a real answer right now. Is the airflow around that housing actually removing enough heat, or are you slowly cooking your components? That's exactly the problem this calculator solves. It uses Newton's law of cooling to calculate how many watts of heat a surface loses to surrounding air through convection. You enter your surface area in square inches, your surface temperature, the ambient air temperature, and then you select the type of convection. Natural convection means still air, no fan. Forced convection means you have a fan or blower moving air across the surface. The calculator handles the rest. Here's the core idea in plain language. Heat transfer by convection comes down to three things: the size of the exposed surface, the temperature difference between that surface and the surrounding air, and a number called the convection coefficient H. That coefficient captures how effectively air carries heat away. Still air might give you an H of 10. Add a moderate fan and that jumps to 100. A high-velocity industrial blower pushes it to 200. The formula simply multiplies those three values together, surface area times temperature difference times H, and gives you watts of heat removed. Now here's where it gets practical. First, motor cooling. You can enter your motor's power dissipation, and the calculator tells you whether convection alone is sufficient to keep it cool. Second, enclosure design. If you're sizing ventilation for an electrical panel, this tells you whether passive airflow is enough or if you need to add a fan. Third, heat sink evaluation. You've mounted a heat sink on a driver board and you want to verify it's actually doing its job at the expected ambient temperature. Every one of these scenarios takes about 30 seconds to check, and the answer is the difference between a reliable system and a thermal failure. Find the link in the description below to use this calculator and read the full engineering guide.